Vehicle as a Resource by Sharon Abdulhamid, Hassam S. Hassanin, and Glenn Takahara.
What if car A and the other cars around it were intelligent? Could it have prevented the accident in the first place? Would it have better mitigated the aftermath of this accident? Imagine a world where all the cars had sensors and actuators with intravehicular communication. Imagine the possibilities. The cars near the accident can send signals to the other surrounding cars to warn them about what lies ahead, if not completely rule out the possibility of an accident. Even though human error exists, the fatality and damage caused can be greatly reduced if we had intelligent cars, if we used vehicles as a resource, instead of just as a mode of transportation. The possibilities are endless. So, what all can a vehicle be used for? Sensing, storage and computing, data relaying, infotainment and localization, to name a few of the uses according to the IEEE paper. Vehicles will no longer just be stuck in the accident but act as a resource of useful information. In VAR sensing, vehicles will be equipped with sensors capable of monitoring surroundings and recognizing objects. Detection from the sensors will ensure that vehicle system takes the appropriate safety precautions to keep the driver safe. At the same time, data about an accident can be recorded via the camera in the form of photos and videos. With the data collected, vehicles can store them in the onboard storage inside the car. With VAR storage and computing, advanced in-vehicle computer will allow vehicles to manage time-critical tasks more efficiently and also enable them to act as a mobile data server. How is it so? For example, a vehicle which would like to know the severity of accident but was out of sight can use vehicle-to-vehicle, V2V, communication, and request information from the vehicle nearest to the accident. This is made possible by wireless messages exchanged between vehicles, which helps to relay the data from the source to the destination vehicle. Such network is known as a vehicular ad hoc network, VANET. This allows the vehicle to make appropriate decision to avoid the accident area. Extending the VAR data relaying concept further, communication can also happen between vehicle and infrastructure, V2I and I2V. Vehicles can communicate with access points like a road sign along the road. Vehicles can even upload data to the internet via cellular communication. VAR infotainment introduces the possibility for always-on internet access. A vehicle about to approach the area of accident can be alerted. In this way, congestion and inconvenience in the area can be reduced. Vehicles can also use self-localization techniques to determine a more refined GPS information about the accident location. Knowing the exact location aids the police and ambulance to assist the accident-affected vehicles. There is a plethora of potentially useful tasks a vehicle can perform. However, this technology is bound to face many challenges in its implementation and adoption by consumers. Here is a list of potential challenges to be reckoned with. For this video, we will be concentrating on two key challenges crucial for the wide adoption of vehicle as a resource. The first and the most crucial challenge concerning users is privacy. A vehicle's resources may be accessible to many users to share and utilize. How can I be sure there is no unauthorized access to the sensors on board and a breach of my privacy? With an increasing number of incidents reporting the hacking of intelligent cars like those of Tesla and Jeep, there is serious concern for the user's safety and privacy. To tackle such issues, a few suggested solutions are virtualization and scheduling techniques for coordinating access to shared resources. The use of personal data vaults, which are individually controlled data repositories, is another viable solution for the safeguarding of user data. The second challenge detrimental to the adoption of VAR is the data quality. As pointed out, there are various real-life use cases for VAR. However, if the data quality is poor, there would be very little use of the results, leading to frustration by the users and a waste of resources. In some scenarios, poor data quality can convey a completely incorrect or confusing message, thus having seriously calamitous effects. A smart and effective solution to this problem would be verifying and analyzing techniques to build quality data reports and history and computing reputation scores, which can be considered in the selection process. Giving feedback to participants about their data quality can also help improve the data quality. Effective solutions as those listed earlier make VAR a truly viable and promising project to be part of future smart cities and nations.
Brought to you by Akash Rendhe, Ang Shichao, Divesh Bayani, Lim Mingquan and Nupur Jain.